Okay, welcome back everybody. This lesson is going to cover one-step equations, and everything about inverse operations is going to be covered as well. All right, let's go ahead and get started. Now, one way you might see one-step equations, any type of equation described, is as a balancing act. Where one side equals the other. Where one side of the equation equals the other side. And that is important. Otherwise, it's not an equation. Equation, I know it doesn't totally have it, but it kind of has the word equal in it. It's just missing that L. It's very much related to being equal on both sides. Now what we're going to do is we're going to look through some of these examples right here, and we're going to ask ourselves, are these equations true or are they false? Are they balanced or unbalanced when x is equal to 3? Because that's what we're going to do. We're going to put in 3 for x in every one of these. So if we put in 3 for x into this one right here, is it a true equation? Well, does the left side equal the right side? Well, 3 plus 3 is 6. And so you got 6 equals 6. And so that would be considered a balanced or a true equation. That's one way you like to put it. It's true. One side, the left side of the equation, equals the right side of the equation. The right side equals the left side. Now in the next example here, we're going to look at the second one here. We've got x plus 1 equals 6. Now, is that true when x is equal to 3? Let's put it in there and see what happens. So when you replace x with 3, you get 3 plus 1. Now, 3 plus 1 is 4. And 4 definitely does not equal 6. All right, so that would be an unbalanced or false equation. You couldn't call that an equivalent equation that's equivalent to x equals 3. Okay, now in the next one here, we're going to plug in 3 for x and see if this works. So when you plug in the 3 for x, you get 3 plus 6, and 3 plus 6 is 9, and 9 definitely doesn't equal 8. 9 equals 9, not 8. So that's another false equation. That's unbalanced. One side does not equal the other, so you couldn't truly call that an equation. Now in this next one, we're going to put in x plus 3 equals 3, and we're going to put in the 3 for x. And see if this works. This seems like it should work, right? 3, x equal 3. We've got a bunch of 3's here. But let's be sure about this. We got 3 plus 3. Well, that equals 6. And oh no, 6 does not equal 3. Not at all. 6 equals 6. 3 equals 3, but 6 does not equal 3. So another example of an unbalanced or false equation. That's not true. Now for this next example here, for x plus 1 equals 4, we're going to put in 3 for x again. When we do that, you get 3 plus 1, and 3 plus 1 equals 4. And finally, we've got a true equation right here. That is completely balanced. The left side is equal to the right side. Both sides equal 4. That's what you want an equation to look like. You want both sides of an equation to be equal to one another. Now let's go ahead and look at this last example right here. We've got x plus 2 equals 5, and we're going to put in 3 for x. And now we have 3 plus 2. Now let's answer the left side. 3 plus 2 equals 5. And 5 does indeed equal 5. So that's another example of a true or a balanced equation. The left side equals the right side equals the left. Let's go ahead and look at some real world math for this next example. It says Jennifer has some video games. We're not sure. She's got some. Maybe she has 100 games. Maybe she only has 1. We're not sure. But she has some video games. That's the variable. And then she bought 4 more games. Now she has 10 games. This situation can be described using the equation x plus 4 equals 10. So I just want to kind of dissect what the meaning of everything in this problem is. So what does the x represent in this particular equation? Well, it represents what Jennifer has before she bought more games. Now, based on the information we have here, we're going to be able to figure that out. If it was just x plus 4 and there was no equals 10, then that would just be an expression, right? Expressions are open-ended. There's no one answer to it, right? Like I said at the beginning, maybe she had 1 game, maybe she had 100 games, we're not sure. But once you make it equal to something, x plus 4 equals 10, now it's an equation. And that equation can be solved. Now the next part right here, it says write 2 different equations that are equivalent to x plus 4 equals 10. Let me show you how this works. What you want to basically do is, let's figure out what x is. What is x? Well, x has to be 6, right? because 6 plus 4 equals 10. So what I want to do is I can just write out any equation, but I want to make sure that in each one of my equations that x is equal to 6. Now I don't care if it equals 10 on one side, I don't care if you add 4. All we are concerned about here is that the x value, when we solve it, is equal to 6. And let's see if that's true for this one right here. So let's say we put a 6 in there, right? 6 plus 7, does that equal 13? Yeah, it does. Yeah, 13 equals 13. That's balanced. That's what you want an equation to be. Now let's see if 6 works here. Does 6 plus negative 5 equal 1? It sure does. So that is equivalent as well. Now notice I didn't use a 4, I didn't use a 10, but I did, however, make sure that the x was equal to 6. So those are equivalent. So as long as you make your x value equal to something that is 6, then you can write any equation. There's any number of equations you could have written for those two examples right there. Okay, now let's get into one of the more important aspects of equations. Now this applies to one-step, it applies to two-step, multi-step equations, all equations. It's called inverse operations. And what we want to do when we solve equations, it's all about doing the inverse. Inverse is just kind of a fancy schmancy way of saying doing the opposite operation. So the opposite of addition would be subtraction. The opposite of a positive would be a negative. The opposite of multiplication would be division. The opposite of a square would be a square root. So it's all about doing the inverse operation or the opposite operation. So what you want to do is you want to focus in, laser focus in on the letter side, on the variable side. Now look at the letter side there. We've got 6x. Now look at what that is. That 6x is presenting itself as multiplication. So what is the inverse of multiplication? So the inverse would involve dividing. So for right here I wrote down divide by 6 on both sides. So that's what you're going to do. We don't need to do that necessarily, but what you do to one side, you do the other. That's called the property of equality. So if you divide the left side by 6, we better divide the right side by 6 because we want everything to be balanced. Okay, in this next example right here, look at the variable side, focus in on that variable side first, and notice it's x plus 18. Now the 18 is positive, it's got a plus sign there. So the inverse operation in this example is going to be to subtract. So the inverse operation is subtract 18 from both sides. Now I'm not really interested in doing the math here, but I just want to show you that you can take 18 away from both sides. And on this example right here, we've got n over 12. Now looking at the letter side, n over 12, what is that presenting itself as? Well, that's whenever you have a fraction is another way to express division, right? Top divided by the bottom, n divided by 12. So what is the inverse, right? What is the opposite operation of division? Well, the opposite of division would be multiplication. So that's what we're going to do. We're going to multiply both sides by 12. Now, as you guys can see, notice how when we applied inverse operations, we always applied it to both sides of the equation. All right, we multiplied the left side by 12. We multiplied the right side by 12. We subtracted 18 here. We subtracted 18 from 29. We divided 6x by 6. We divided 216 by 6. Now, I didn't actually do any arithmetic there, but I'm just showing you what the inverse operation is doing. Now, in this example right here, you might want to be careful. There's a plus sign there, and you might think, oh, the inverse of addition is subtraction. However, be careful, because it's really more about what that integer is. What's that number? The value there is -3. So I want to make it so that the variable side is just a. If I want to get rid of the -3, I'm going to add 3, because the inverse of -3 is +3. So then what you do to one side, you do to the other, and that's what you do. So we're going to add 3 to both sides. Now in the next example right here, you might notice that there's a minus and there's a minus here. Now if you remember from integers, you'll notice that when there's a minus, we better clean that up. We better simplify that. So really we should write m plus 4. Before we do any inverse operations whatsoever, we should write m plus 4 and then think about doing the inverse operations. So the inverse of plus 4 is going to be subtracting 4. So we're going to subtract 4 from both sides. And the tricky part about this next example right here is that it's just a variable. It's just minus t. Now remember, another way you can write that is negative 1t. Negative 1t. Now it's a little bit more obvious that it's multiplication. So how do you undo multiplication? Well, you're going to divide. So we're going to divide both sides by negative 1. So those get canceled out. And then you just have to do negative 6 divided by negative 1. So this was all about just figuring out what inverse operation needed to be applied to the problem in order to solve it. And remember, these are all one-step equations. When you get into two-step equations, things are done a little bit differently, but inverse operations don't really change. Now let's get down to actually solving these. So for this first example, we're going to look at the variable side, and we notice we have plus. Well, the inverse of plus 23 is going to be minus 23. Now what you do to one side, you must do to the other. So if we take away 23 from the left side, and the equal sign separates the sides. Sometimes you might have had a teacher talk to you and say, well, that's like a river there. So the river separates the two sides. So we're going to take away 23 from both sides. Now these 23s right here, the purpose of doing that is to get those to cancel out. You're like, well, what's the purpose of that? Well, the purpose was to get x by itself. We wanted to get the variable by itself. So now we have x equals, and now we just have the computation here. We have negative 8 and we have negative 23. We want to put those together and we're going to get negative 31. Now at this point, what you can do is check your solution. You should always be checking your solution. I know a lot of times when we do math, we're like, I didn't get it wrong. I do math perfectly. I never make mistakes. But that's probably a mistake thinking that way, because we all make mistakes. We're all not perfect. Let's see if that negative 31 makes that a balanced, or what we call a true equation. So if we put that negative 31 in there, well, negative 31 plus 23, well, that equals negative 8. Well, so does the right side. The right side equals negative 8. That checks off. That is true and verified, and we can go on to the next problem thinking, hey, I know I got this correct. I am 100% confident that I am getting these correct because I checked my answer and everything seems like it's a-okay. Now this next example right here, we've got a fraction next to a letter. Now when there's a fraction next to a letter, that's presenting itself as multiplication. This is 2/5 times t. Well, what's the opposite of multiplication? Well, the opposite of multiplication is division, right? Division. Now with division, you have to be able to flip the fraction, right? You have to flip the second fraction. So if we're going to divide both sides by 2/5, we better flip 2/5. So we're going to make it 5/2, right? Which is the reciprocal of 2/5. And then what you do to one side, you do to the other. So we're going to multiply both sides by 5/2. Those cancel each other out, leaving us just with 1, right? 5 times 2 is 10, 2 times 5 is 10. So 10 over 10t really is just saying it's 1t. And what does 1t really say? It's really just t. And when you multiply the right side by 5/2, you get 6/5. Now if you're wondering, where the heck did I get 6 over 5 as an answer? Well, let's show you. Now one way to do this is to not do any cross canceling at all. You can just do 12 times 5, which is 60. And then do 25 times 2, which is 50. And then if you reduce that, you could divide by 10. And if you reduce that, you get 6/5. Now some of you might be thinking, well, aren't you supposed to change that to 1 1/5? And actually with algebra, it's perfectly acceptable to keep it in ratio form or as an improper fraction. It's actually easier sometimes to keep it in ratio form. So 6/5 is how I got it. Let's check out 6/5 and multiply that by 2/5, see if that works. Well, yeah, 2 times 6 does equal 12, and 5 times 5 equals 25. So that is definitely a true equation. That's a balanced equation. That's what we want it to be. Right. For this next one here, we have 8 times x, 8x, equals 104. So looking at the variable side here, the x side, that's multiplication that is presenting itself. Now the inverse of multiplication is going to be division. So we're going to divide both sides. Now when you divide the left side, we're going to divide the right side also. So we're going to divide both sides by 8. So those cancel out. So 8 divided by 8 is just 1x, right? 1x, which is just x. We know that that's x. And then 104 divided by 8 is 13. And let's check that out. Let's see if that works. Put in 13. 8 times 13 is 104. And 104 equals 104. See, when you really think about it, there's no way to miss an equation problem. You should be able to work those out, check your solution, and know with 100% certainty that you got it right. Or you got it wrong. But at least you can walk away from the problem knowing you got it right or wrong. That's a good feeling. Sometimes we walk away from our math problems and we're thinking, yeah, did I get it right? Did I get it wrong? And we're not always sure about that. Checking your answer does not hurt. Now in this next example here, we've got y over 4. It's division. So we're going to do the inverse of division, which is going to be multiplication. So we're going to multiply the left side by 4, and we're also going to multiply the right side by 4. Now the 4's canceled out on the left side, and you're only left with y. 8 times 4 is 32. That's our answer. Y equals 32. Now let's check it out, see if this all makes sense. Put in 32 for where the y was. So 32 divided by 4 is 8, and 8 equals 8. Okay, so that does it for this lesson on one-step equations. You're going to definitely want to practice this and have a good handle on how to solve one-step equations using inverse operations before you ever step foot into dealing with two-step equations. You definitely want to know how to do this. So make sure you go through the practice problems that accompany this lesson, and that should do it. Everyone have a great day. See you later.